This video is for Math 95, and I'll be going over the problems on sample test number 2. The first thing I want to point out is that you'll have this formula sheet on the rules of exponents. I'll make sure that you have this with the sample test so you can see what the formula sheet for your test will look like. And then you can put anything else that you'd like onto a 3x5 card. Starting out with number 1, we want to write the cube root of x to the 5th, y to the 7th using exponents. And so we want to write this as x to the 5/3 and y to the 7/3. You've got the power on the top and the root on the bottom. You can say, x to the 5th, y to the 7th to the 1/3 power, but it hasn't really been simplified. You technically are rewriting this using exponents, but you've left it in an unsimplified form. You've got the parentheses, you've got these powers being raised to powers, whereas this is a much more simplified form. You just have each variable raised to a power. So this answer is much preferable to the other one. Problem 2 is the opposite. Problem 2, we get y to the 7/9, and we want to write this using radical notation. So that'll be the 9th root of y to the 7th power. You can also write the 9th root of y raised to the 7th power, and these are both equivalent. There's really no difference between them. Okay, well, let's see here. Problem 3, we want to simplify this radical expression. Square root of 12 x to the 7th. So the way that I've shown doing these problems during class is I'll split this up into things that are perfect squares and things that are not perfect squares. And remember, if you haven't square rooted anything, it has to stay under the square root. So this will be a 4 times 3. The 4 is a perfect square, the 3 is not. And we can put x to the 6th here and x to the 1st there. The x to the 6th is a perfect square, but the x to the 1st is not. So this will square root. Now we're going to apply the square root, and so this will come outside of that radical as 2x to the 3rd. The square root 3x stays the way that it is. Okay, let's see. Problem 4. Is the same type of problem. Here we've got the square root of 36, a to the 7th, b to the 3rd. So I'll do the same thing I did in problem 3. I'll make a radical for things that are perfect squares and a radical for things that are not. The 36 is a perfect square. That's great. With the a's, we can put a to the 6th here and a to the 1st here. And with the b's, we can put b squared here and b to the 1st over here. Now, let's square root all these perfect squares. We're going to get 6, a to the 3rd, b to the 1st, and we'll be left with a square root ab. Okay. Let's see here. Next, we've got these rules of exponents problems. And so that formula sheet that will come with the test should be very helpful in completing these problems. So, problem 5, we've got 4y over x to the minus 3y squared. And that's all being raised to the negative 2 power. And then after we deal with that, we're going to have to multiply it by 2x squared y. Well, I guess I'm going to simplify inside the parentheses first. So we're going to have 4y x to the 3rd over y squared. So I just move that x to the 3rd up on top, x to the minus 3 up on top, and it'll become x to the 3rd power. Also, I've got a y to the 1st here and a y squared here. This will cancel out one of these, and so we'll end up with 4x to the 3rd x to the third over y to the first, and that's to the negative 2 power. I'll throw that in there. And then the next thing I'm going to do here is take the reciprocal. Now I'm all rid of those negative exponents, okay? So let's just apply this exponent here. That'll be y squared over 16x to the 6th times 2x squared y. And if you want to put this over 1 to remind yourself that it's on top of the fraction, that's fine, because this 2 is going to cancel with the 16. The x squared will cancel out 2 of these and leave us with x to the 4th. So on top we'll have y to the third power, and on the bottom 8x to the 4th. Okay, so that's problem 5. Problem 6 is similar. So let's go ahead and take a look at that. Problem 6. 8ab to the 5th. And then, let's see, 3a over a squared b to the minus 7th raised to the negative third power. So I'm going to do this the same way I did problem 5. I'm going to work inside here first. I'll leave that 8ab to the 5th alone for a few minutes. And this one I'll have 3ab to the 7th over a squared to the negative third. And then I'm going to flip this over and make this a positive 3 power. A squared over 3ab to the 7th to the third power. And also I can cancel this a with one of these a's. So let's see what we come out with here. We'll have a over 3b to the 7th, and that's going to get raised to the third power. So let's raise this to the third power. A to the third over 27b to the 21st. And this will be 8ab to the 5th over 1. Let's see, the 8 and the 27 don't cancel. They don't have any common factors. B to the 5th will cancel out 5 of these and leave us with b to the 16th. The a here and the a to the 3rd there are going to make a to the 4th power. So we'll have 8a to the 4th on top and 27b to the 16th on the bottom. And that's number 6. All right. Okay, problems 7 and 8 have to do with complex numbers. (5 plus 2i plus negative 9 plus 7i minus negative 2 plus 12i. Okay, so if you want to get rid of these parentheses, then you have to, right here you could say plus negative 9 plus 7i. That's fine. I'm going to write this as minus 9 plus 7i. I mean, whether you say plus negative 9 plus 7i or minus 9 plus 7i, it's the same thing. I'm not a big fan of double signs. I like to always reduce double signs to a single sign. Same thing over here. I'm going to have minus minus. That makes plus 2 minus positive 12 makes minus 12i. Okay? All right. So now let's collect our like terms. We need all of our real numbers tallied up together. 5 minus 9 is negative 4 plus 2, negative 2. 2i and 7a make 9i. 9i minus 12i, negative 3i. This is negative 2 minus 3i. Problem 8, we're going to be multiplying. Now notice the difference between problem 7 and problem 8. In problem 7, you've got plus and minus signs in between the parentheses, whereas in problem 8, the parentheses are bumped right up next to each other, which indicates multiplication. Because one of the common mistake people make is they start trying to multiply all this stuff, but these are telling you you're adding and subtracting them, so please don't do that. Let's see here, we're going to multiply 3 minus 8i times 1 plus 10i. And so in this one, you have to distribute, you have to FOIL, right? 3 plus 30i minus 8i, and then minus 80i squared. Okay, so these two pieces in the middle are like terms, and they are going to make positive 22i. And then this I squared is negative 1. So 3 plus 22i plus 80. So our answer is 83 plus 22i. All right. Now on the last page here, you've got 3 equations to solve. The first one, it involves a square root or radical. Okay? So in problem 9, you've got 7 plus square root 2x minus 5 equals x. So, the first thing we want to do is get the square root by itself. So we're going to subtract 7 on both sides. Square root 2x minus 5 equals x minus 7. And now we're going to square both sides. So this will just be 2x minus 5. Over here, x minus 7 times x minus 7 is going to be x squared minus 14x plus 49. So let's see, let me create some more space over here. So we want to subtract 2x on both sides. Let's see. And then, well, let's just add 5 on both sides at the same time. So over here we'll have 0, x squared minus 16x plus 54. Let's see here. Now, we can factor this if we can split 54 up into factors that add up to be 16. I'm not sure if we're going to be able to do that because 54, right, 1 times 54, 2 times 27, 3 times 18, 4, no, 6 times 9, and that's pretty much it. None of these add up to be 16. So we're going to have to use the quadratic formula on this one. And you've got, I mean, you can see on the test paper, you've got the quadratic formula right there. It's actually on the test page rather than on the formula sheet. So even if it is factorable, you can still use the quadratic formula. There's nothing wrong with that. But if it's not factorable, you kind of have to use it. So let's see here. This is going to be, we've got A is 1, B is negative 16, C is 54. So this will be negative 16 plus or minus negative 16 squared 4 times 1 times 54. And then on the bottom, 2 times 1. So let's see, 16. 16 squared should be 256. And then minus, let's see, 4 times 54 should be 216. Let's see here. Right. And then we've got a a 2 on the bottom. So inside here, what are we going to get? We're going to get 40. 256 minus 216 is 40 divided by 2. So let's go ahead and approximate this. Square root 40. 6.325, I believe. We round off to 3 decimal places. On the first page of the test, it asks you to round all irrational numbers to 3 decimal places. So this will be 16 plus or minus 6.325 over 2. So we're going to get 2 answers. 16 plus 6.325 over 2 and 16 minus 6.325 over 2. So this one is going to be 4.838. Okay, and then over here, 16 plus square root 40 divided by 2, that's going to be 11.162. So there's our 2 answers. Okay, so that's problem 9. You can see there's a fair amount of work there. That's why all of these problems are, well, problem 9 and problem 11 have the most work. Problem 10 is really just doing the quadratic formula. So let's take a look at problem 10. I'll leave that quadratic formula up there. Problem 10, x squared minus 3x plus 5 equals 0. So there's no work to get this in standard form. This is standard form. Ax squared plus bx plus c equals 0. So we've got a equal to 1, b is negative 3, c is positive 5. We'll apply this into the quadratic formula. So negative, negative 3. Remember, this negative sign comes with the formula. This negative sign comes from the value of b. Plus or minus b squared 4ac to a. All right, so positive 3. Now, remember that when you're squaring a negative number, you're going to get a positive answer. Negative 3 times negative 3 is going to be positive 9. And then over here we've got minus 20 divided by 2. So 3 plus or minus the square root of negative 11 over 2. So at this point we can split this into the complex part and the real number part. Okay? So you've got your 3 halves as the real number part. You can call that 1.5 if you want to. Here, we pull out the square root of negative 1 as I, and that leaves us with square root 11 divided by 2. So, let's approximate that square root 11 divided by 2. Square root 11 divided by 2. And so this is going to be 1.5 plus or minus 1.658i. And those are our 2 answers, 1.5 plus 1.658i and 1.5 minus 1.658i. All right, that's number 10. Now, problem 11 is a little bit trickier. There's a fair amount of work to do before that problem is in standard form. So let's take a look at it. X plus 3 squared, 2x plus 1 times x minus 2 plus 3. All right, so x plus 3 times x plus 3 is going to be x squared plus 6x plus 9. Here we'll get 2x squared minus 4x plus 1x. So that'll be minus 3x minus 2. And then we've got a plus 3 on the end. So I'll just combine these together and make plus 1. There we go. All right. Then we can subtract all of this. And so that'll make this side 0. Over here we'll have 1x squared minus 9x minus 8. Now it looks like we need the quadratic formula for this one as well. Because this is a minus 8, we don't have factors of 8 that have a difference of 9. So let's go ahead and run this through the quadratic. A is 1, B is negative 9, C is negative 8. So we'll have negative 9 plus or minus square root negative 9 squared minus 4 times 1 times negative 8 all over 2 times 1. All right, so this will be positive 9. And then we'll get 81 plus 32, right? This negative and this negative make a plus over 2. So 9 plus or minus square root of, looks like 113 over 2. So 9 plus square root 113 over 2, and 9 minus square root 113 over 2. Let's see what we get from those when we approximate. 9 plus square root 113 divided by 2, 9.815. 9 minus square root 113 divided by 2, negative 0.815. So, there's our two solutions for this equation right here. All right, so that's it for the sample test. If you have any questions about this, I'll be happy to talk to you about it. We'll have an opportunity in class. You can also come to my office hours, whatever works for you. But if you have questions, please do get them resolved before the test. Thanks.